let's talk about gas collection. Now, we've done several experiments where we have produced gases, and what do we measure with those gases? Well, we carry out those experiments in an open beaker, and so gases are produced. It's real important to carry out experiments to produce gases in open containers, or at least containers that aren't sealed, because if you seal up a container, produce a gas inside of it, that gas expands a lot more than the liquid or solids that it was made from. And if you have a rigid container, that container is likely to shatter and explode outwards. So that's why we've carried out experiments in open containers. The problem with that approach is that when the gases are produced, they're quickly lost. We can still make measurements though. We can take the mass of what's left in the container, compare it to what we started with, and we can tell the mass of the gas that was lost. But what happens if we want to do more measurements? Well, we have a gas collection apparatus here, a gas collection setup that we'll be going through today. Instead of carrying out our experiments or our reactions in an open container, what we're going to do instead is we're going to carry them out within this Buchner flask. Now, this Buchner flask is not an Erlenmeyer flask. What it is a 250 milliliter Erlenmeyer flask with a nozzle. Now, what this nozzle can do is you can attach a hose onto it. And we're going to be attaching our hoses from our Bunsen burners. If you carry out an experiment in here, or a reaction in here that produces a gas, that gas can go one of two ways. It can go out the top, or it can go out through the hose. If we put a cork on this, we force all the gas that is produced out of this hose. Now, we're very careful not to make this a sealed system. If we were to plug up this hose, that would seal all the gas in here, and when we produce too much gas, it's going to expand against the glass, cause that to shatter outwards. So we definitely don't want to do that. Now though, all of our gas comes out the end of this tube. So why does that do us any good? Well, it really doesn't. We need some way to capture and measure this gas. So that's what the rest of this experimental apparatus is for. Now what we have here is we have a ring stand with a clamp attached. Both of these pieces of equipment are not in your lab station, a little too tall. So when you do this experiment, you'll be checking these out from me. On top of that, we have our culture dish, or fish bowl, as people in the class like to call it. Our culture dish, and right now it's filled about halfway to 2/3 of the way with just regular tap water. Aside from this, we have a 100 milliliter graduated cylinder. Remember, a graduated cylinder is the only way that we can measure volume in a lab accurately. You don't want to use a beaker, even though it has these milliliter measurements on it, or an Erlenmeyer flask which has the same milliliter measurements on it. Those are not accurate. A graduated cylinder is the only accurate way in our lab to measure volumes. Our graduated cylinder is also filled with tap water. Now it's filled above the 100 milliliter mark. Not so high that it's going to flow out the spout there. What we're going to do with this is we're going to cover it, flip it upside down, and put it down in the water. And what does this do? Well, there's still a little bit of gas left in it, but the water is keeping that gas contained there. We can clamp this here so that the end of our tube is underwater, and we can see that the gas level stays there. And why are we using this? Well, remember back to our Buchner flask. With a cork like this, all the gas that we produce is flowing through this hose. In order to capture that gas and make measurements on it, what we can do with this hose is stick it underneath the water and up into our graduated cylinder. That's going to make it so that all the gas that's produced in the reaction that's occurring in this Erlenmeyer flask is going to go out through this hose bubble upwards and push the water downwards. So right now we have an initial reading on our graduated cylinder. If we produce gas, so don't put your mouth on glassware, kids. Hopefully what you were able to see there is the gas that I blew in through the top of this container force its way through the tubing and into the graduated cylinder, pushing down the water. And wherever that water ends up, that's new level of water. That tells you the difference in the beginning and end marks. That tells you the volume of the gas that you produce. Now we have also captured our gas or trapped our gas within this cylinder here. So we can do a number of other things with that gas and make other measurements with that gas. So this is our gas collection apparatus. You'll be using it to test several different things. Good luck with it.